In section 6.4, we're talking about trigonometric functions of any angle. And you have already worked through the angles in a unit circle, so now we're gonna reference that a couple of times and also talk a little bit about the unit circle in this video. So we're going to be evaluating trigonometric functions of any angle. We're going to use reference angles to evaluate trig functions also. If you have a value, an xy value here, as you know already, then the x value here is going to be the length here. If angle theta is here, this being your initial and then your terminal side. And then this is going to be y. And then when we're talking about sine and cosine, if this is a unit circle, so we have these values here. If I'm using if I'm trying to define my trig functions, then when I have the sine is going to be opposite, and so in this case the opposite is going to be my y over the hypotenuse, which is the radius here. Okay, all right, so now let's talk about that in terms of the unit circle. And what do you know about the unit circle? On the unit circle, you know that your radius is 1. So when you know that radius is 1, and then you go to find sine, cosine, tangent, and cotangent, secant, and cosecant, you know, the same way that you've done when the radius is not necessarily 1, then look what we find. We have sine of theta is still the opposite, which is our y, over our hypotenuse, which is our radius. But now that we know that this is the unit circle where the radius is 1, then what do we know? We know that sine is going to be y over 1. So the sine is just going to be the y value. And we can work through that with cosine also, and we end up finding that cosine theta is going to be just x because our radius is 1 here. That being given, then we can say, okay, that's why we know that this ordered pair here is going to be the cosine on our unit circle, cosine, comma, sine of theta, that ordered pair. So the cosecant function we know is the reciprocal of the sine. So if we look back here, then we see that sine and cosecant, see how those are reciprocal, and we know that relationship already from the previous section. Secant function is going to be the reciprocal of the cosine, and cotangent function is going to be the reciprocal of the tangent function. Let's look at an example. This time we have the point -3, is a point on the terminal side of theta, and we want to find the sine, cosine, and tangent of theta. So if we start out with just a coordinate plane, and we have the point -3, 4. -3, 4 is going to be somewhere in the second quadrant. All right. So what we want to do is we form a right angle here, then we know that along the x-axis we have 3 and -3. We're going to use the -3, and then we're going to use 4 here. And so now that information is going to allow us to find the length of the hypotenuse. So we're going to use the -3 squared plus 4 squared, or you can recognize this as being a 3, 4, 5 triangle. So the hypotenuse would be 5. And if that's the case, then we have sine of theta is going to be our opposite over our hypotenuse. Cosine theta is going to be our adjacent over our hypotenuse. And let's see, we also need to find tangent here. So both of these have the same denominator. So you can do it in terms of sine and cosine, sine over cosine, or you can say tangent is going to be our opposite over our adjacent. Okay, and so you notice you could have also said that would have been this 4 over this -3 here for your tangent. And now in the second example, we've got the point 2,5 is a point on the terminal side of theta, and we want to find, again, the sine, the cosine, and the tangent of theta. So again, we're going to start out with our coordinate plane. This time, the point 2,5 is going to lie within our first quadrant. Okay, we use that to make a perpendicular. And our x value is 2, our y value is 5. And so this time we're going to have to do a little work to find the hypotenuse. So we've got 2 squared plus 5 squared is equal to our radius squared. And so And that's going to be 4 plus 25 is equal to the radius squared. And so then our radius is plus or minus the square root of 29. So we're going to use root 29 in this case. Right? And so now that we have that, and we're not going to rationalize these this time, we're just going to leave them in the form, the original form. So opposite over hypotenuse is going to give us 5 over root 29 this time. Of course, we could rationalize that by multiplying by root 29 over root 29. Cosine of theta is going to be giving us adjacent. And so we got to remember that theta is here, adjacent over the hypotenuse. And then our tangent is going to be 5 over 2, opposite over adjacent. So let's look quickly at the signs within each quadrant. So since what we have is cosine, sine. So when we are in quadrant 1, everything's going to be positive, sine, cosine, and tangent, because in that case, the x and the y are both positive. Okay, so this is your x, this is your y. And then in the second quadrant, we've got sine is positive, so sine is our y value, so we know the y values are positive in the second quadrant. Cosine is negative, and then tangent, since tangent is sine divided by cosine, which it would be a positive divided by a negative, tangent is going to be negative. In our third quadrant, x and y are both negative, so that means sine and cosine are both negative, and then sine over cosine would produce a positive, and that makes tangent positive in this case. And then in our fourth quadrant, we've got sine is negative, our y value is negative there. Our cosine is positive, which is our x value, and of course a positive or a negative divided by a positive is going to give us a negative, and so tangent is negative in that fourth quadrant. All right, on this example, we're going to state whether each value is positive or negative or 0. So basically, it's just using that last slide that we have. So let's look at those together. All right, so the cosine is 75 degrees. So when you're doing A, you might want to think about, okay, well, 75 is going to lie in the first quadrant. And so in the first quadrant, what do we know? That sine and cosine are both going to be positive. So in this case, this one's positive. In the second one, when we're doing B, you've got the cosine of 3 pi. So 3 pi, we know one revolution is 2 pi, so 3 pi is actually going to be 3 pi is actually going to land back here. So what we're talking about is the negative x-axis. And for the negative x-axis, what we're going to have is, we're looking at sine is going to be 0. Okay? And then, so for the next one, we've got cosine of 5 pi. So cosine of 5 pi is actually going to end up landing in the same place as B. Okay, it's the same angle because it's just an additional revolution around. If you were to add 2 pi to the 3 pi, we would get 5 pi. But what is the cosine in that case? The cosine in that case is going to be negative. And then the sine of negative 3 pi. So when we're doing D, the cosine of negative 3 pi. So what we're doing is we're making a negative, and we go 1 pi, and 3 pi is going to end up back in that same place. So what we have here is we have a sign that is again 0. All right. On this next example, I am telling you that the sine of theta is 4/5 and the tangent is less than 0. And we're going to use that information to find cosine and cosecant. All right. So the information that I've given you is enough to figure out which quadrant we're in. So you know that the sine is positive. So if the sine is positive, that means it's in the first or the second quadrant. If the tangent is less than 0, then that means that cosine has to be negative. So that means that we're going to fall within our second quadrant. We're going to be here and not here. So we have this angle right here, and the sine is 4/5, so we could say that's opposite over the hypotenuse. So when we draw our triangle, our hypotenuse is 5. Here we have theta. Our opposite is 4. And we are left finding out what our adjacent is, or our x value. So hopefully you can recognize that as being a 3, 4, 5 triangle, so we don't have to do the work. And now if we want to find cosine of theta, and that's going to be a negative. Cosine is going to be adjacent over the hypotenuse. So we have negative 3/5. And then we are looking for cosecant, and cosecant we know is just going to be the reciprocal of our sine, so that's going to give us 5/4. This time we got angle theta's in standard position with the terminal side in the third quadrant, and we're going to find the exact value of cosine theta if we know what sine is. So we're going to start out again. Their coordinate plane is going to lie in the third quadrant. And we're going to start filling in the information we know. We know sine is negative 1/2. So our hypotenuse we could say is 2. And here's theta. And our opposite is going to be negative 1. And that makes sense because in our third quadrant, our y value is definitely negative. The other thing we know is that our x value is negative. So when we find out what this is, we're going to have to make sure that we have a negative here. So let's go ahead and put it there. So we have, you might recognize this, and if you don't recognize it, then we're going to end up using the Pythagorean theorem to work it out. So you've got 2 squared is equal to 1 squared plus, we're looking for our x squared, and so 4 minus 1 is equal to x squared, and that means x is going to be equal to the square root of 3. So we got negative root 3 here. All right. So once we figure out what that is, then we can say that the cosine theta is going to be our adjacent, which is negative root 3, over our hypotenuse, which is 2. Okay, and hopefully you recognize that from your unit circle. Example 6, we've got another angle theta in standard position with the terminal side in the fourth quadrant. And this time we want to find the exact value of sine theta if cosine is 4/7. All right, so this one we're not so lucky as to have it being on the unit circle. So we're lying in the fourth quadrant. And we know that the cosine is 4/7, so that means that's 7. And here's theta. And our adjacent is 4, which makes sense that it is definitely positive. And we know we're going to be looking for a negative value here. So we're going to have to use again, the Pythagorean theorem to find out the value of y. And this time we get a negative root 33. Okay. And once we have that, then we can say that the sine is going to be our opposite over our hypotenuse. Now we're going to talk a little bit about reference angles. If theta is an angle in standard position, its reference angle is going to be the acute angle theta that's formed by the terminal side of theta and the horizontal axis. So what that means is, let's say we have an angle that is greater than 90 degrees, and we want to come up with a reference angle for it that is between 0 and 90 degrees. Then the way you find that in this case is it says that you're going to use the acute angle formed by theta and then the terminal side, okay, and the horizontal axis, okay? So the blue line here is our terminal side. So the acute angle formed between that blue and the horizontal x-axis is going to be this angle here. All right, and so that's our reference angle. And there are different ways to find it depending on which quadrant that lies in. In this case, since it lies in the second quadrant, all we need to do is say 180 minus actually theta wouldn't be here, minus our theta to find out what that acute angle is. If it's in radians, then we're going to use, this is pi minus theta. And so let's look at a couple of examples here. This tells you what to do in each case. So in the first case we have, it is between 0 and 90 degrees. In the second case, that's exactly what we looked at. So we're looking for the red part here. So we would say 180 minus theta. When it lies in the third quadrant, we're looking for this. So what we would do is we would take theta and we would subtract 180 from that one. And basically what that does is it gets rid of this piece here, leaving us just with that acute angle. And then in the last one, what we would do is we would take 360 and subtract theta when it's in the fourth quadrant. So here we're going to find a reference angle for each one of these. The 213 degree angle, so on A, the 213 degree angle, if we look at these, let's look at the two slides together. Here we have 180, and then we've got 270. Okay, so if we think about where that's going to lie, then we have it somewhere in here. Let's do that in a different color. Somewhere in here. So that means what we need to do in this case is we need to say our 213 minus our 180. And then we're going to get a reference angle of 33 degrees. Okay, so that's for A. And then for B, we've got theta is 1.7. So 1.7, if you look at pi over 2, is about 1.5. So it's between pi over 2 and pi, which means it's going to fall in our second quadrant. So we're looking at something like this, and if that's the case, then we need to say 180. But this one is, you can tell that this one it's not labeled as degrees, so it's labeled in radians. So we're going to work with this one in radians. To find a reference angle, we're doing pi minus 1.7, and we can leave it as pi minus 1.7. That's fine. And the next one, C, we've got 144 degrees, so this time we're working in degrees. That's less than 180, but greater than 90. So again, we're falling in the second quadrant. So since we're falling in the second quadrant, we're using the 180 minus the 144. Which gives us 36 degrees as our reference angle. Okay, we're going to look at common trigonometric values and angles here, talk a little more about the unit circle. So this is the unit circle, and this is the information that you should know about the unit circle. Let's look, for instance, at just one of these angles. Right here, what we have is a 30-degree angle, okay? And let's talk about, as you did on your activity, how we get those values. If that's a 30-degree angle, and I drop this perpendicular here, then what we know, and let's come out, and what we know is that this is a unit circle, so our radius is 1. If this is a 30-degree angle, then we know opposite that is the shortest side, and the shortest side is exactly half the hypotenuse, which is a half. And then the side opposite the 60-degree angle is root 3 bigger than our second one, so we end up with root 3 over 2. So when you're looking from using that triangle and we're looking for the sine of theta, then we're using our opposite over our hypotenuse, which just ends up giving us 1/2. And that's where we get this from. That's our sine. And then when we're looking for the cosine of theta, we end up using our adjacent over our hypotenuse, which is root 3 over 2 over 1, which gives us root 3 over 2. And we have our cosine. So there you have your cosine, sine, being your x, and your y values as the coordinates around your unit circle. And those values, those are values that you need to know. You need to be able to memorize there. So now you can use your unit circle to help you find answers quickly. Okay, so let's look at two slides together again. So if we're asking to find sine, cosine, and tangent for each value, and let's say the first value I give you is 150 degrees. Okay, so if you have your unit circle memorized, then you go and you find your 150-degree angle, and you notice it's here. So from there, you notice that you should be able to quickly find your sine of theta is 1/2, and your cosine of theta is root 3 over 2, negative root 3 over 2. And then your tangent, of course, is going to be your sine over your cosine. So that's not, but you should quickly be able to figure that out. So your sine is going to be 1 over negative root 3. And if you rationalize that by multiplying by root 3 over 3, you're going to end up with root 3 over negative 3, or negative root 3 over 3 there. Okay, so there's an example of how you should be able to use your unit circle. And on this next example, we're asking to determine the values of theta for which the sine is equal to 1/2 just by looking at the unit circle. And we want theta being between 0 and 2 pi, which means I want my answer in radians. So we want sine to be 1/2. So let's quickly go back to that slide with the unit circle. We want sine to be 1/2. So sine is the same as our y value. So we know our sine is going to be positive. So that's going to be here, and then it's also going to be here. So the answer to that question is that pi over 6, okay, and 5 pi over 6. And you see those, that's 5 pi over 6, and that's a pi over 6. Okay. And this is just about using inverse trig functions. If the value of one of the trig functions of any angle is known, a calculator can be used to determine the angles having that value. So if we're looking at this right here, find the values of theta where theta lies between 0 and 360 degrees, and we want to do it to the nearest tenth of a degree. So you notice here that we're working in degrees. So you want to make sure that your calculator is set in degree mode. Okay, and let's say that I give you cosine of theta is equal to 0.9266. Okay, then the first thing you're going to do is you're going to use to go to your calculator and make sure you are in degree mode. Okay, so turn on my calculator. See if we can. All right, so I'm going to mode, and you notice that here I am in degree mode, so that's good. And then we were given cosine, so I'm going second inverse cosine of 0.9266. And that gives me theta is about 22 degrees, basically. All right. And now let's look at another example where theta is between 0 and 2 pi. So this time we know that we're using radians. And let's say I tell you that tangent theta is equal to 3.009. And I want to find the answer in radians, okay? So I want to know what theta is in radians. Again, let's go back to our calculator. We're going to have to switch from degree mode to radian mode. And then I'm using my inverse tangent of 3.009. And that tells me that it's at about 1.25 radians, okay? All right. And that's all I have for section 6.4 today.